Hey everybody, Mr. Beckstrom here, and I'm doing an example from section 8.2. So this is the law of sines again, and this is probably one of the harder examples from this section. So we're going to take a little bit of time on this one today, and this is one of the examples that I get some of the most questions on. I like to do this one in class, so please feel free to use the forums to ask questions on this if you have them. This is finding the other angles and the sides of a triangle. In this one, they are giving us here, looks like two of the sides and one of the angles. So let's first of all just kind of draw a ambiguous triangle here. So I'm just going to start off by just making a triangle here. And so if we have a big A, a big B, a big C, and remember the little letters are always opposite the sides of the big letters. All right, so they are giving us like this side here, so that's a 9. The little b is a 2. And the big A is a 50 degrees here, 50 degrees. All right, so we have a side, and then an angle. So the angle is not between our two sides. So what we have is a side, angle triangle. Now, side angle is what we call one of the ambiguous cases. Why? Because this is a weird case. We can either have no triangles depending on the length of the sides and the measure of the angle. We can have one triangle, or in some cases, we can actually have two triangles. It really depends on these lengths and measurements here, and it's really hard to kind of show you how we can do it. But I'm going to try to do it the best that I can. So let's say this length can be as long as we want. But let's say this angle here is fixed right here, and we have this side right there, which is also fixed, and then we also have this side that is fixed here. All right, imagine that this side is fixed. Okay, so we have this angle here. We'll call this angle A. We'll call this side here B, and we'll call this side here little a. So this is our angle. This is our side that's opposite this angle, and this is this side here. So this is a side angle triangle. Now notice this angle is not fixed because we don't know what it is, so it could be anything. Now, depending on how long this side here is, if I were to swing this down, right, I could possibly make a triangle that looks like this, right? Or if I were to keep swinging this side this way, I could also possibly make a triangle that looks like this if I were to keep swinging it like this, right? So, and in both of those cases, this angle remains the same, this side length here remains the same, and this side length here remains the same. So this is one of the, so just giving us this angle measure, this side length, and this side length here, I could possibly have this triangle and this triangle here. So here's a case where they just give us the measure of an angle, this side length and this side length, and I could have this larger triangle here, or I could have this smaller triangle there. Now, if this side here, A, is really short, let's say it stops here, there's really no triangle that could be measured. And if it's too long, there's really no triangle that could be measured or built, excuse me. So it really depends on these lengths. So how do we do this? Well, the way that we're going to do this, and I'm going to erase some of this just so there's not so much measured here. The way we're going to do this is we're going to set the triangle up like this, and then we're going to find out what this height is, right? We're going to find out what this height is. And the way that we're going to do that is, well, if we know this angle here, sine is opposite over hypotenuse, so we're going to set up a sine function. We're going to find this height here, and then we're going to compare this height to this length here, and that's going to be able to tell us how many triangles that we're going to have, right? If this length here is shorter than this height, then that means we're not going to be able to even form a single triangle. If it's the same length as this height, we're going to be able to form exactly one right triangle because it'll fit exactly right there, right? If it is greater than the height but less than b, then we're going to be able to form two triangles like we saw before, because we're going to kind of be able to form like, if A is between this height here, so if it's somewhere between that height there and somewhere less than b, we're going to kind of be able to form like two triangles, right? Like one like that and one like that. And if A is greater than B, then we're only going to be able to form like a single triangle that goes out like this. So those are our four cases, and they're going to talk about the four cases on page 536 in the book. Oh, I'm sorry. Nope. They're going to talk about it on page 538 in the book, those four cases there. All right, so what do we need to do then in order to figure this out is we need to put it in this form here, and then we're going to take this, we're going to look at the sine, or b times the sine of a, and then we're going to compare it to this side over here, okay? So let's go ahead and start doing that. So I am going to erase all of this stuff here. I'm going to set my triangle up. Excuse me if things aren't exactly straight. Okay. So I kind of set my triangle up here. For me, my angle is 50 degrees. My opposite side from my angle, from my big A, my little a, is 9 degrees. 9 degrees. A length of 9. And my side here, my adjacent side to that angle, is a measure of 2. So my height here, height is going to be, it's going to be 2 times the sine of that 50 degrees, right? 50 degrees, because the sine is opposite over hypotenuse. So this is going to be approximately, I'll use my calculator here. So make sure I'm in degrees. So 2 times the sine of 50 degrees. And so we are going to 1.53. Is that right? Let me just double check. 2 times, yes, 1.53. All right. So 1.53. All right. So that means that this height is 1.53. And this 9 here is greater than this height. And it's also greater than this B here, which means that I'm going to have a single triangle. I'm going to have a single triangle, and it's going to look like this, right? It's going to kind of look like that, right? Because this length is so long compared to this side that this side can only go one way, can only go out to the right here, way out this way. So let's start. So this here is going to be my A. Let me see, my B is over here. This will be my C. So I have 2 and I have 9. Let's start doing, so we know our A is equal to 50 degrees. My B, we don't know what that is yet. My C, we don't know what that is yet. My little a is going to be 9. My little a is going to be equal to 9. My little b is going to be equal to, opposite my big B is going to be equal to 2. And my little c, we're going to need to figure that out as well. All right, so let's get working on this, and we're actually going to have one more hiccup along the way that's going to be important here, so we're going to be talking about that as well. Okay, so let's go ahead and get started. And remember, we're going to want to use exact angles and measurements where we can instead of approximations. So the first thing is we're going to be wanting to use the sine of 50 degrees over 9, because that's one side of an, or one sine of an angle over the opposite side, and that's going to be equal to, so really we need to find the angle B over here first, because we know the opposite length of the side there. So the sine of B over the opposite side length, which is 2. All right, so let's do this. So the sine, or 9 times, this is just cross multiplication, 9 times the sine of B is equal to 2 times the sine of 50, sine of 50 degrees. So sine of B is equal to 2 times the sine of 50 degrees. I don't know what happened there with my mouse. 50 degrees. So B, apply the inverse sine to both sides, is equal to the inverse sine of 2 times the sine of 50 degrees. Okay. Let me just double check my work here. Oh, I didn't divide by 9, did I? And that would be over 9. And that would be over 9. Okay, so going back to my calculator, make sure you have an inverse there. I did not draw that very nicely. So inverse sine of 2 times the sine of 50 divided by 9. All right, so I'm going to go to my calculator here, and I'm going to do second inverse sine, and I'm going to put this whole top in parentheses. So open parentheses, 2 sine 50 degrees, close parentheses for that, close parentheses for the top of the numerator, and then divide by 9, close parentheses, and I am going to get 9.80. The actual question asks you to do 2 decimal places. Now here is something really important, and that's when we do the inverse sine function, we have 2 possible angles. And this means that, remember, there are 2 angles that will give us that value. There is the angle that we're looking at, the 9.80, but we also have another angle that will also give us the same value, and that's 180 minus that angle. So if I look at 180 minus 9.80, I also have to consider this angle here as well, 170.2, because that's also another angle on our unit circle that will give us the same value as 9.80. But looking back at this, I know I have a 50-degree angle on my triangle. So 50 degrees plus 170.2 degrees is over 180. So I can discard the 170.2. So I don't have to use that one. But there are certain cases where we do have to consider that other angle when we're doing the inverse sine function, and we're going to actually have to use that other angle instead in order to make this work. So just remember that whenever you do the inverse sine, you have to look at not only that angle, but 180 minus that angle as well. Okay, and this is just for the inverse sine, not for the inverse cosine, because the inverse cosine is 360 minus that angle. All right, so so we can discard that, and so we have the 9.80. So this is approximately 9.80. So I'll go over here and put in my 9.80, and we are done with that. And then, so 9.80. So now all we have left is big C and little c. Well, big C is easy now that we have two of our angles. So 180 minus 9.8 minus 50, right? Yep, minus 50. And that's going to give us 120.2. So 120.2. And then the last thing we need is just this little c over here. And we'll just use the law of sines for that. So the sine, and remember I'm going to keep using a because those are exact values. So the sine of 50 over 9 is equal to, and then we have to use the c's for this last one, the sine of 120.2 all over little c. And then if you cross multiply and divide, you get little c is equal to 9 times the sine of 120.2 divided by the sine of 50. And let's go ahead and get that. So 9 times the sine of 120.2, and then divided by the sine of 50, and 10.15. So this is approximately 10.15, and that is our last value. All right, so this one is a beast. It is the hardest out of the different cases for the triangles. Remember, for most of them, you're only going to get a single triangle. For example, the side angle side, for the side angle angle, the angle side angle, but for the side angle, that's an ambiguous case. For the angle angle, you can have any number of possible sized triangles. Just think about it. 60, an equilateral triangle is a 60, 60, 60, and you can have, any size triangle there. All right, if y'all have any questions, let me know, and I hope you have a great rest of your week. Thanks.